Hi everyone, welcome back to my channel FRM Unplugged. So today we will be discussing and doing some numericals on normal distribution. So in our previous sessions on the paper 2 or rather book 2 of FRM part 1, which is the quantitative one, we have already covered probability, the first two chapters. The first chapter is probability, the second chapter was random variables. So today we will be taking up the third chapter, which is common univariate distributions, and for that see, this chapter has a plethora of distributions. It has normal, Poisson, student's t, chi-square, exponential, log normal, F distribution. There are so many. But from the exam perspective, not only from the exam perspective, but also from the real life use case perspective, the normal, the Poisson and the student's t finds the most common application in the real life business scenarios. So GARP expects us to have a reasonably thorough and rigorous knowledge on these three, whereas for the balance, it is okay if we just have some knowledge on the parameters or how it is defined. But for this first three, normal, Poisson and student's t, we are expected to go deep into it because there will be problems, numericals, which will test our concept, not the basic elementary ones. Okay, so we'll straight away dive into the numericals on the normal distribution. The first question is, which distribution does not tend to approximate the normal? So we know, right, for binomial, what happens when n increases, this becomes normal. For Poisson, what happens? When lambda increases, this it approximates to normal. For Bernoulli, there is no such case. So the correct answer is A. Okay. Now, the second question is a random variable x that is normally distributed with a mean of 10 and variance of 25. So mu is equal to 10 and sigma is equal to 5, which is square root of variance, right? Without using a calculator, we have to find out the probability that x lies between 1.75 and 21.65. So obviously, I think we all should be, this much we should be having in our fingertips, that these kind of problems should always be solved by first making it standardized, which is calculating the z value. So if we calculate the z value, for the lower range, right? So we just want to know for a standard normal variable, what is this value and what is this value, and so if this is the A and this is B, so we just need to know the probability. So probability that a random variable lies between A and B is this area, right? So we just need to find out this A and B. So if we take 1.75, no? So 1.75 minus 10 by 5, this is how much? This is equal to, let's say, 8.25 by 5, which is 0.16, sorry, 8.25 divided by 5 is 1.65. Wait. This is equal to 8.25 by 5. This is equal to approximately minus 1.65. Similarly, if we have to find out the other end, so this is a standard normal. So this is 0, this side is negative, this side is positive. Here we have found out minus 1.65. Similarly, the right hand side is 21.65 minus 10 by 5. This again 11.65 by 5. This approximately becomes 2.33, right? So this is 2.33. Now here we have no option but to have it learn by heart these z values. Okay, so the way to remember it in the exam is, for the two-tailed distributions, just write like this: 90, 95, 99. Just write like this. Okay, for two-tailed, this will always be more, and for one tail it will always be less. So this is two tail, 1.65, 1.96, 2.58. You remember that formula, x plus minus 1.65 s. So here the s is 1, right, and x is 0. So effectively it is minus 1.65 and plus 1.65. The original formula is x bar plus minus 1.65s. For a standard normal distribution, x bar is 0 and the standard deviation is 1. So it effectively comes down to minus 1.65 to plus 1.65. This is for two-tailed. Two-tailed, 2 is more than 1. So just remember this 1.65. And one tail, just here 1.65, just put it here 1.65. Here is 1.28 and here is 2.33. Just remember it this way. So here then if this is 2.33, right? So the area to the left of B is how much? 99%, right? And the area to the left of minus 1.65 is how much? 10%? No, it is not 10%, it is 5%, because this is two tail and this 10 is divided into 5 this side, 5 this side and 5 this side. So 5%. So here to the left is 99, this to left is 5%. So the area between them is 99 minus 5 is equal to 94%. This is the answer, which is point B. Okay. Now let us look at the third problem. Each of the following is a property, Each of the following is a property of the normal distribution except for, so we know it is fully, normal distribution is described by two parameters, mu and sigma. So here some of the times we tend to overlook what they are asking, whether we have to find the true or the false. So here all are true except one is false. Just let us not get confused, because these kind of questions I have seen people, including myself, we got confused when we did these exams. So this is 3 are correct, 1 is false. Okay, so A is correct or false? A is correct, right? C is correct or false? C is also correct. D is correct or false? D is also correct. Then what else is remaining? B. B is false. So this is not 95%, this is approximately 99%. So B is false and B is the correct answer. Okay, now let us go to the fourth question. So here it is just saying that mu of A is 45K and standard deviation of A is 4.5K, and the person has actually got 48K, means the person who bought the tire got it 48K. Similarly, mu of B has a mean life of 38K, and whereas this guy is 2.08K and he actually got how much? He got 40K. I'm just writing as K for the thousands. Okay, so here the way to approach this problem is see, we obviously, our common sense tells us that this is just 48 and this is 48, so this is better, A is better than B. It's not like that. So it depends on how far this 48 is from this mean, right? In terms of the standard deviation. So the farther the person is from the mean on the right hand side, which is increasing, right? The more the distance from the mean, the better off it is. Why? Because we know that is the very characteristics of normal distribution. That means that all the actual value of the random variable is clustered around the population mean, and the farther we go from the mean, the probability of the random variable having that value reduces drastically. That is why the probability of the tail events are very, very less, right? So we will just calculate the standardized Z value. So here it is how much? 348K minus 45K. So this is the sample mean minus this is the population mean. So 3K by 4.5K is how much? 3K by 4.5K is approximately how much? 0.67. Okay. And this is how much? Okay, 40 minus 38K by 2.08 is how much? 0.96. Okay. So this is 0.96, which means, so this is the standardized normal variable, normal curve. This is 0. So this is somewhere around 0.96. Let's say this is 1, this is 2, like that. So this guy, this person who has bought B tire is here, and the person who bought A tire, which is, what was the value? 0.67. So obviously this guy is better off. See, B, even though his absolute mileage of 40K is less than 48K, but still he is better off because he is more further from this mean. And the probability of this 40K is supposed to be less than the probability of this 48K for the 45K value. So he is getting, I mean, there is very less likelihood of a person having 40K. So this guy got it, so he is better off, right? So that is the answer. So that is how we will have to approach it, correct? Now, on the fifth question, there is, again, this is similar to the first one. Since the scores are getting inflated every time, they have just standardized this. They have decided to they want to give a standardized grades in addition to the sometimes it happens for more precise assessment they give the standardized grades. So like this it is given. So if you are to judge by the standardized, which class did Camilla do best in? So obviously we will have to find out the Z value for all the four. So Z value for, let's say, WRT01, okay, sorry. Again the same logic as the first one, okay. WRT01, if we do know, let me do the calculation here. So this is 3.55 minus 3.15 by 0.3. Similarly, the second one you do 3.60 minus 3.05 by 0.45 and do the third and fourth. So we will find that for WRT01 and PSY01, okay, this is the highest and this is the lowest. See, these are just calculations, so I am skipping it for in the interest of time, and this is the same as the previous, but just here. So in this case, I took this example because in the earlier case there was a difference in scores, yet the person who got the less score is better off. Here there is the scenario is similar with one difference. Here this 3.55 and 3.5 for these two subjects, WRT and PSY, both are same, but we will see that here, for WRT01, here the Z value is more and here the Z value is less. So even after having same score, this lady is better off in WRT01 than in PSY01, like that. So sixth, now this is again a reasonably straightforward thing. See, Z is 0 is obviously it's 50-50. We know it is symmetrical, right? So these two are same. No issues here. Now, this is the second one. So what is for 0.99, right? So Z is 0.99. We have to look at so let us, we have the Z tables in our Schweizer and FRM book. So if we take the value of Z value and we check that 0.99 is how much? 0.8389, right? Which means So 0.99, this is 0, this is 1, and this is 0.99, which means this portion is how much? 83.89%. So this is the percentile. So they are asking for percentile. And one slightly different way of approaching is when the z value is minus 1.29. Usually, I mean, there are some z value tables where we have the negative values also. But in this case, just use this logic, that is, this is 0, this is minus 1.29, this is plus 1.29. So whatever is this figure, this area here, same is this area. So whatever is the z value, the figures that we get from the table are the area of the curve to the left of that figure. So if z of 0.99 is 83.89, this means the area to the left of 0.99 is 83.8. So here, if we look at 1.29, 1.29 is how much? 1.29 is 90.15, right? Which means this area, this entire area is 90 point, how much was this? 1.29, no? So 90.15, okay? This is 90.15. So area to the left of this. This is 90.15. So the area to the right of this will be how much? 1 minus 90.15 is equal to 8.85. So 8.85 is the answer, because since it is symmetric, this 8.85 and this 8.85 are same. So without using negative value, we found out by using the positive value only, but we assumed, and which is the correct assumption, that this is symmetrical. So whatever is in the right hand side, similar, it's a mirror image of the left hand. So that's how we do it. So this was a simple one, but then again, we should be kind of quick with the z value tables also, should this kind of questions come in. Okay, now the seventh one, right? So again, this is similar to the previous question. So 1.48, okay? So z is less than 1.48. So if we go to 1.48, 93.06 is the answer, right? So 0, 1, here is 1.48. So this portion area is how much is coming? 1.48 is just 1.4, you take the row, and 0.08 take the column. So 1.48 is how much? 93.06%. 93.06. So less than this is this area. And z more than 1.6 is, again, this is 0 and this is, let's say, 1. So this is 1.6. So this area, this is 1 and this is, let's say, 1.6. So more than 1.6 is this area. So obviously this area is supposed to be less, right? It will never be 80 or 90%. So if we use the table, right, 1.6, in 1.6 has how much? 94.52. So 94.52 is this area. This area is 90. So this area is 1 minus 94.52. Like that. And similarly, we just discussed this, the area. The same way we can figure out for this last two values. You can do it yourself, because I think that is self-explanatory. Okay. Now this is slightly, you may or may not get such a difficult question, but still I thought, I mean, there are certain questions, where GARP, I have seen from my experience, and I have seen by asking, I mean, I know because I have asked a few students who have appeared in the previous exams in 2015, 16, 18, 20, 22, like that. So then there were certain questions like this where you could arrive at the final answer by rejecting or agreeing to the other answers. So you actually may not know how to do this, but you could have the ability to reject it. We will just see what I am trying to say. Now, so we know that a normal mixture of two normal distributions is also normal. So if it has n of if it has n of 2 1 and n of minus 2 1, obviously the mixture distribution is bimodal, which is there are two modes, because the mean is so here is this mean, this is minus, so there are two means. The frequency of occurrence of the random variable is the maximum frequency. There will be two maximum frequency, that's why it is bimodal. The mixture of distribution has a mean of 0. Okay, so 1 is plus 2, 1 is minus 2. Obviously, since mean is a combination, is a plain addition, so this is also correct, right? Now, the probability, the variance of the mixture is greater than 1. Is it correct or not? Let us see. Variance of A plus B, okay, is equal to variance of A plus variance of B plus 2 covariance AB. So variance of A, okay, has the same, that is the components of the same variance 1, but their expectation means differ. So the variance of the mixture is greater than 1. So this is 1, this is 1. So obviously this will be more than 1. So this also we know C is also correct. Now the probability that X is less than 2 is approximately 50%. This we are not very sure. So this will be most probably the false, because the rest 3 are correct, right? So we may not, because this is slightly convoluted discussion. So we can skip this, but we can still answer it, because there are bound to be questions where we will never have 100% surety of that we are able to do it and we are correct. So this way we can still attempt a question and we can get an answer, because there is no negative marks. So we can try to answer questions by rejecting the or like this, by assessing the other options. Okay. So let us look at the 9th question, right? This is an important question from the exam perspective. It's not a simple problem, but it's a difficult problem, but we all should be able to solve it, because this is a simple application of our understanding of the normal variables, random variables which has normal distributions. So just keep this in mind. If there are two normal, if there is one random variable A which follows normal, and there is another random variable B which also follows normal distribution, sum of them and the difference of them, they will also follow a normal distribution. So here what we know is mu A is equal to 0.1, sigma A is equal to 0.1, mu B is equal to what? 20%, right? And sigma B is also 20%. So, and the correlation is 0.4. Actually, now the final B rate is 30% and this is 12%, right? So we have, what we have asked is, what is the nearest to that fund B outperforms? So we will have to think about it, that B and A, we will have to subtract it and then find the distribution of this B minus A to know the probability. So if we have to, so for B, then for knowing the B minus A's probability, we need to figure out the Z value. For calculating the Z value, what we need this is what? This is the sample difference of rates minus population difference of rates divided by sigma of B minus A, right? This is the formula for Z, assuming that this Z is for A minus B, correct? sorry, B minus A. So again I am repeating, this is simple. B and A we are given, and we just have to know what is the probability that it has outperformed. Means what is the probability that B minus A is more than 18%. 30 minus 12 is more than 18%. So to know the probability, we have to find out the Z value. And Z value of what? A we have to find out, or B? No, we have to find out for B minus A, which is the difference. So for finding B minus A, we need the sigma of B minus A, which is standard deviation. Now sigma of B minus A is equal to square root of variance of A square plus variance of B square minus 2 covariance AB. Now this covariance AB we can write as rho into variance A into variance B. Sorry, standard deviation of A into standard deviation of B, like this. So we just need to plug in the figures. Variance of A is 0.1 square, variance of B is 0.2 square, minus 2 into covariance AB. In place of covariance AB, we will just plug in rho into root variance of A into root variance of B. So if we plug in these figures, we will get this from our calculators. 0.2 square plus 0.1 square minus 2 into 0.4 into 0.2 into 0.1, which is 18.44%. Okay, so this is 18.44%. This one, the standard deviation of the difference of the rate. So Z of B minus A is how much? The sample difference. What is the sample difference? 30 minus 12 is 18%. And what is the population difference? 20 minus 10. Population difference is what? 20 minus 10 is 10 by 18.44. So 18 minus 10 by 18.44 is 8 divided by 18. Is 0.4338. This is equal to 0.4338. So 0, this is 0.4338. What they are asking is the difference should be this or more, which means this side the area should be. What we are asked is what is the probability that the difference will be 18% or more, which means the difference should be more, which means, see, this is the standard normal distribution of the difference. So the difference should be more than this, right? So this is the area. So for this, what we will find out from the Z table, we will find out what is the Z score for this 0.4338, right? So 0.4338, if we make 0.44, it is approximately 67%. Okay, this is approximately 67%. 0.67 it's coming, which means for Z what we know, it is the area to the left of it. So therefore we are required to find the area to the right. So which is how much? 1 minus 67% is equal to 33%. So this is the answer. Point C. This is one important question that we need to keep this in mind. This is a very, very important question that we can expect, because this is a hardcore application of our formula. This is just not the formula, this is the application, right? And then we have a final question here. So this is basically, again, this is like the one that we did earlier. This is slightly convoluted, though it is not very difficult, but we can still make it and make an attempt to see. Okay, so see, it just says that some variables have been transformed. So now let us straight away come to the options, right? What we are saying, x of f and x of g are, which of the following statement is true? So let us look at the false ones. Point D, xf and xg are approximately normal? Never, because normal is additive, not multiplicative, right? So this is xf is x1 into x2, xg is x1 by, so it is not correct. This is false. Then we should expect the sample correlation of xa and with xb and xc with xd to be exactly equal to rho. This is also not correct. I'll come to it. xc is no longer normal. X of e is 3.0 plus 5. So this is also false, right? Because this is normal, because this is additive. So this is a constant term, and this is also a constant into that variable. It is not the multiplication of the variable. It is the multiplication of the random variable with a constant. So if A is normally distributed, A is a random, or rather X is a random variable that is normally distributed, then A into X is also normally distributed, where A is a constant. So C is also not correct. So what we are left with? Point B. So B is correct even otherwise also. Even if we don't go by this logic, this is approximately equal. So just because their correlation is rho, it can never be exactly equal. It will always be approximately equal due to sampling error. So even if we did not go through A, C and D to arrive at B, we can also look at it on a standalone basis and judge. So if it is mentioned that correlation parameter is constant, right? So between x1, x2, x3, and again accordingly the transformed variables also will have the same correlation. But due to sampling error, there is thing called sampling error, right? The sample mean moment may not exactly be the same as the sample as the population mean moment. The same logic applies here. So it will only be approximately, it will never be exactly. So with this we complete so we covered 10, I think all these 10 are 10 different type of problems in normal distribution, and we have had a very rigorous assessment for normal distribution. I don't think there would be any different kind of a numerical other than the ones that we just discussed. So with that we complete the normal distribution. We will take up the Poisson and the student's T in my later lectures. Thanks for listening.